Quantum information science is looking at ways of using quantum mechanics, so the rules that govern atoms and photons, to build computers that are faster, that can solve problems we can't solve now, and also to communicate with each other securely, send messages that no one can listen to. And the work we're doing here is looking at using atoms and light together to build the foundation of this new quantum information system, that is the quantum gate. Computers are made of gates. We have ones and zeros that control each other in gates in classical computers. In a quantum computer, you need quantum gates that work with quantum bits. And so with this kind of strong interaction between light that you could make using this system, you could potentially build a quantum computer. Normally light travels very quickly, but it doesn't have to. When it moves through something, it can slow down. And in this experiment, we've brought it to a complete standstill, and we have light that is stationary in space.
By getting the light to stay stationary, it means that we can increase the interaction time with all of the atoms. And if you can increase the interaction time, it means you can get stronger interaction from one photon as it affects all of the atoms in this cloud. And that potentially could be used to implement optical gates for future quantum computers. We have a lot of technology involved in the experiment, and being able to control it to such a fine degree that we can actually store photons and keep them as a stationary pulse, I find just really impressive and really interesting from kind of a fundamental perspective.
Potential applications in every field of research, from medical research to pure physics to engineering, financial sector, everything. The next thing for us would be to actually do this, store two pieces of light simultaneously in our system and have the stationary light causing this interaction. Then we can see how strong it is, whether there's any noise, anything that gets in the way of being quantum compatible, and we'll take it from there and see what happens.
There's definitely kind of a fun, intuitive link to sci-fi ideas where, in Star Wars you might see a blaster pulse getting frozen by the Force. Of course we're not using Force, we're using light-atom interaction. But it's definitely fun to intuitively think about light being just stopped at a speed where, you could plausibly walk past it if we were able to store it for long enough.